What is MIG welding? MIG welding stands for Metal Inert Gas Welding, a process commonly referred to as gas metal arc welding or GMAW by the American Welding Society, AWS. It is also widely known in industry as wire welding due to the continuous wire feed system involved. In MIG welding, a thin consumable wire acts both as the electrode and the filler metal. This wire is fed automatically from a spool, which may be housed within the welding gun or in the main welding unit. It travels through a flexible conduit liner, continues through a welding hose, and exits via the contact tip of the torch or gun nozzle. Upon pulling the trigger on the gun, the wire feed motor engages, feeding the electrode forward. The welding current is activated. The shielding gas is released simultaneously. An electric arc is generated between the wire electrode and the workpiece, rapidly heating both metals above their melting points. The molten metals coalesce and solidify to form a metallurgically bonded joint. The base metal refers to the material being welded, while the filler metal is derived from the melting electrode wire. MIG welding always introduces filler metal into the weld joint. Because the electrode wire melts during welding, MIG is categorized as a consumable electrode process. The wire passes through wire feeder, flexible conduit liner, contact tip at the torch nozzle. Simultaneously, shielding gas flows through the same torch. The gas passes through a gas diffuser and exits around the wire through the nozzle. The shielding gas, commonly a blend of argon and carbon dioxide (CO2), protects the molten weld pool from atmospheric contamination, such as oxygen, which causes oxidation, and porosity, moisture, leading to hydrogen embrittlement, nitrogen, which can create brittleness and porosity. The shielding gas is supplied from high-pressure cylinders, and the pressure is regulated via a gas regulator to maintain optimal flow rates, typically 20 to 25 CFH for mild steel applications. Electrical setup and polarity. MIG welding typically uses direct current, or DC. In most configurations, direct current electrode positive, DCEP, also known as reverse polarity, is used. In this setup, the electrode is positive, the workpiece is negative. This polarity concentrates more heat on the electrode, improving penetration and arc stability. The electrical circuit must be closed for current to flow. The current travels from the power supply, through the welding torch, into the workpiece, and returns to the machine via a ground clamp or work lead. Machine controls and parameters. All key process parameters are controlled directly from the welding power source. Voltage, affects arc length and heat input. Wire feed speed, WFS, controls amperage and deposition rate. Polarity, typically DCP as noted. Gas flow rate, set via regulator, depending on material and environment. The gun trigger acts as a simple on-off switch, simultaneously starting wire feed, gas flow, and electrical current. To summarize, MIG welding is an arc welding process that utilizes a consumable wire electrode, automatically adds filler metal to the joint, requires shielding gas from a high-pressure cylinder, is highly suitable for welding steel, stainless steel, and aluminum, with appropriate equipment and gas blends. Standards and references. Professional MIG welding should conform to standards such as AWSD 1.1, Structural Welding Code, Steel, ISO 14341, Welding Consumables, Wire Electrodes and Weld Deposits. ASME Section 9, Qualification of Welders and Welding Procedures. Proper adherence to these standards ensures structural integrity, safety, and weld quality in critical applications.